This passage 6, it's a conflicts passage. We know it's conflicts because it says student 1, student 2, student 3. These will usually say student or scientist or maybe method. In our DRC approach, C stands for conflicts, which is carefully read. This is much more of a reading passage than any other passage in the test. You need to understand the differences and understand what's going on in the passage in order to be successful in the questions. Just a reminder, this passage is important to figure out when you take it because it can be time consuming if you're not a strong reader. So if you're a strong test taker or you have time to finish the test, generally I recommend doing conflicts first. Get it out of the way so you know how much time is left. If you're a slow test taker or a weak reader, maybe do conflicts last. So that's up to you to figure out the best order that works for your pathway through the test, but you have to consider when to do conflicts. The first thing you do is to identify the conflict. It's the first paragraph of the passage. The conflict in this passage, 3 students were asked to estimate the sun's lifespan that take into consideration the mass and the energy emission of the sun. Your next step is to identify the differences. I would say either annotate and or draw pictures. I like to draw pictures to help me remember, but you do what works best for you. Okay, student 1 says energy is produced by the combustion of hydrogen and oxygen. So hydrogen and oxygen combine for combustion. It's a little problematic because hydrogen and oxygen together can also create water. So this student's explanation might be a little bit off. 1 kilogram of hydrogen consumed creates 10 to the 8th joules of energy produced. So I'm just going to draw that out the side, helps me remember. At the beginning, the sun was composed entirely of hydrogen. Well, that makes the question of where did the oxygen come from? So the student's explanation may not be sound. And then the sun's lifespan is 10,000 years. Student 2, energy is not produced by the sun. That's different than student 1. The sun formed when an interstellar cloud collapsed under the force of its own gravity. So I'm just going to draw a cloud and some arrows pointing in, collapsing. The collapse converted the cloud's mechanical energy into thermal energy, so mechanical into heat. This was stored in the form of a solar core. It produced 10 to the 41 joules of energy, and it's about 10 million years old. Student 3, energy is produced by fusion. 4 hydrogen fused together to form 1 helium, so I drew that. 1 kilogram of hydrogen consumed to about 10 to the 15 joules of energy. And then we have the sun was composed entirely of hydrogen at the start of its lifespan, and the sun is about 10 billion years old. So here's what my passage looks like. I obviously drew these on the computer as we went through, but the first time I do them, I draw them in pencil. It's a little bit faster. I approach these passages with the read, reread approach, the same idea we do with questions. Quickly read through once and then break it down as I go through. I think this should take you somewhere between 2 to 3 minutes to get through, and then the questions are pretty quick. Read and reread for the questions, quick read through to orient yourself, reread and breaking it down. Number 34, which the students asserted that the sun is emitting energy due to reactions involving some form of hydrogen. We definitely see that in student 1 and student 3. Student 2 is all about a cloud collapsing, so our answer is G. Number 35 is a supposed question, so you have to insert a bit of your own knowledge here. Suppose student 2 had done another estimate and found that it was 10 to the 42 joules emitted. Would most likely revise the estimate of the sun span to be. So we see 10 to the 41 was 10 million. We're going to add one more zero, 41 to 42, right? And it's now 100 million. Even if you didn't know that for sure, just go with the base of 10, right? So it's going to, the only one that has that base of 10 is choice C. Number 36, studies on the radioactive decay of materials in Earth rocks, moon rocks, and samples indicate their solar system is at least 4.5 times 10 to the 9 years old. these results contradict which student? So 4.5 times 10 to the 9 is 4.5 billion. So that would definitely contradict student 1 and student 2, which says the sun is only 10,000 years old and 10 million years old. So our answer is G. Which of the following statements identifies a flaw in student 1's discussion? Actually, we already noticed that flaw when we were breaking it down. Combustion requires oxygen, but student 1 did not include any oxygen in the sun's composition. He says it's entirely hydrogen at the start of its lifespan, so oxygen just magically appeared from somewhere. So your answer is A. Number 38, based on student 3's discussion, to produce 16 helium, how many hydrogen are needed? So we see you have 4 hydrogen fuse for 1 helium, so 16 times 4 is 64, or choice J. Number 39, based on students 1's description, the interaction of the 2 types of molecules involved in the sun's energy would yield which of the following substances? We noticed this already also. Hydrogen and oxygen combine to make water, so D. Number 40 is a supposed question. You're going to have to think about it a little bit. Can't just point and find. Suppose the sun began producing energy 5 times 10 to the 9 years ago. That's 5 billion years. Based on student 3's estimate, approximately how many years of fuel does the sun have left? So student 3 says it was 10 billion years of fuel. That's how long the Earth has to live. So 10 billion minus 5 billion is 5 billion, which is 5 times 10 to the 9. So G. Here's where these questions fall in reporting categories, so you can see if there's a particular type of question that might throw you off. By all means, reach out if you have any questions. We'll end with a silly joke about the sun. How does the sun say hello to the moon? With heat waves. Have a good day.